I want to make an observation to start off with that I think kind of says something neat about our world and our industry, and in particular, this little Ruby community we have. I first gave this talk a few months ago in Stockholm, Sweden, and there are at least 2 people in this room today who were also in the room then, and I just think that's kind of neat that I can go to another continent and give this talk and come here and see some of the same people. I hope that we as a community continue to make and take opportunities to see each other and talk face to face. I think that's a good thing. This is kind of a personal talk. It's a talk about a strategy and a philosophy that has kind of shaped my career and has served me really well, and it's one that I've tried to teach to programmers that I've had in training classes or had the opportunity to be a mentor to. And since it's a personal talk, there are going to be a lot of stories. And the first story happened in late 2005 when I was in the process of shifting from kind of toying with Rails on the side to, using it full-time in anger and becoming a full-time Ruby programmer. And so I was having a conversation on the phone with my friend Mike Clark, or maybe I should say my Ruby friend Mike Clark, although I like this picture better. And Mike was telling me about his Rails project. He was a little farther down that path than I was. But he said, I really like this project. You should find yourself on a project like this. It's giving me a chance to do a deep dive and look inside at Rails' internals. I think that's a really good thing. And then he said something that struck me immediately and I've never forgotten. He said, I like to visit all the turtles. And, I knew immediately what he was talking about. He was referring to the old joke, about the man who asserts firmly that the earth rides around on the back of a giant turtle, and some whippersnapper says, well, okay, but what does the turtle stand on? And the old man says, you think you're very clever, Sonny. It's turtles all the way down. This phrase has entered our vocabulary. We've already heard it once in this conference in a talk yesterday. This is a screenshot from the Borderlands video game. And in our field, the phrase turtles all the way down, refers to the layers and layers of abstractions that we sit atop of when we work today, each one building on top of the other. Various kinds of purists, especially from the Smalltalk and Lisp communities, like to use that phrase to emphasize the consistency that all the layers in their platform are exactly the same, are composed of the same kinds of things until you get down to the layer where they're not, of course. If that's what you care about, you may, do something crazy like have the Y Combinator tattooed on your forearm. This is one of the results you get when you use Google image search to find images, and your search terms are turtles all the way down, believe it or not. But most systems and most platforms aren't all that consistent. You have layers built upon layers, and they're all different. They're all made of different things, and they're all aimed at providing different kinds of abstractions. How much of this do you need to know as a programmer? Is it possible to be happy and productive as a programmer only understanding the level of abstraction that you've chosen to work at? And for most of us in this room, it's probably Rails. How much do you need to know about what goes on underneath? And it's a question that takes some careful thought, because one answer is nothing, and I'm going to explain why I don't think that's the right answer, but it can't be everything either, because there's just too much. Eric Sink, a well-known Windows and .NET developer, wrote a blog post not long ago where he sort of tried off the top of his head to map out all the different layers of abstractions that .NET programmers have to build on top of when they work. I don't like ever putting things on a slide that are false, so I'll just call out, there's one thing he writes here that I think isn't necessarily always true. Abstractions reduce performance. They certainly always have bugs and increase overall complexity. Sometimes, though, an abstraction well chosen and well implemented can be a locus for optimization that otherwise wouldn't be possible and actually make things faster. But in any case, Eric Sink wrote this blog post about the .NET abstraction pile, and it kind of goes on for a while, and you can't learn all that stuff. When people talk about this, they often refer to a famous 2002 article by Joel Spolsky called The Law of Leaky Abstractions. Unfortunately, most of what people remember from this article is that term, leaky abstraction, and we complain about abstractions that leak a lot. And of course, some abstractions leak more than others, and some leak in different ways than others, or in worse ways or better ways, and that's mostly what we debate. As an example, I saw this on a Stack Overflow post, had an argument with a friendly coder who was mildly damaged by the law of leaky abstractions. It's very hard to convince him of using any new framework or toolbox at all. That guy's kind of missing the point. As anybody who's ever read, oh, I missed that slide. Okay. This is what I get when I modify slides the day before. There's a book by Charles Petzold called Code that sort of starts at binary numbers and starts building up. And if you've ever seen that book, you know that even machine code is an abstraction on top of other things. So the real point of Spolsky's article was that all non-trivial abstractions to some degree are leaky. And it's not, the fact that an abstraction leaks doesn't make it bad, it makes it an abstraction. The question is, how do they leak? And do they leak in transparent ways or opaque ways? And usually, the worst way abstractions leak is when they break. As Neil Stephenson said, it's commonly the case with technologies that you can gain the best insight about how they work by watching them fail. And that's pretty cool if you are trying to figure out how they work inside, right? But most of the time, that's not what you're trying to do. You're trying to make something else work. And then it fails, and you are greeted with a stack trace from the bowels of this thing that deals in terminology that has nothing to do with the level of abstraction at which you think you're working, right? It's like when a clock breaks, and you're suddenly faced with gears and cogs and springs and things that have nothing intrinsically to do with the notion of time. And it's easy to see why this happens, because somebody building a library that implements an abstraction is going to be focused quite naturally on making it work properly, more than making it fail well, right? And for one thing, it's hard to imagine all the different ways that people could misuse your thing and make it break. And for another thing, that's not the most interesting part of the problem. And for a third thing, when that implementer sees something break, it's not as jarring to them because they understand how it works inside. So that stack trace or whatever isn't nearly as impenetrable to them as it is to us. So it doesn't seem like quite such a big deal. Really good abstractions will take care to make this better. This is a recent comment from Jim Weirich. You can tell the maturity of a framework by the quality of the error messages it produces. I think that's true. However, in practice, the quality of said error messages generally ranges from appalling to merely bad. Spolsky's real point was this. In teaching someone about COM programming, remember this is 2002, it would be nice if I could just teach them how to use the Visual Studio wizards and all the code generation features, but if anything goes wrong, they will not have the vaguest idea of what happened or how to debug it and recover from it. So with that long intro, this talk is about visiting all the turtles, why and how. What you need, the importance of knowing what goes on underneath that first level of abstraction, and why and how to go about it. And so it's time for another story. My second job, full-time job after I left college, was at the University of Texas at Dallas. At that time, at any rate, university computing departments were great places to learn a whole bunch of stuff because, these days there's really only one kind of computer, right? But back then there were a bunch, and you got crazy, weird stuff donated to you from alumni that had gone to work for this or that computer company or whatever. And because it's a donation, you can't say, we don't know how to use that, so no thanks. You take it and you make it work. And I worked with a guy there named Billy Barron. And we were both pretty young guys. And but the two of us, pretty quickly got the reputation in this group of programmers and sysadmins as the guys who could figure out what was wrong when everybody else was stuck, right? And, not to denigrate the others, there were some great people there. But we had this reputation. And so an enterprising student that worked for us saw this and kind of wanted to learn our secret. So independently, separately, he asked us how we learned all that stuff and how we got that way and how he could get that way. And the interesting thing was that Billy and I both told him that it was something that our very first mentor had taught us. And the second interesting thing is that even though we went to different schools and had never met each other before we ended up at that job, we had the same mentor. It was this guy, David Lipke. Not David Lipke, who's a well-known Clojure programmer, but David Lipke, as an aside, from about 1993 to 2003, he was the VP of operations at AOL and was the guy behind AOL Instant Messenger. But, that's not the time I knew him. Billy and I both told this student independently that the way we were able to figure out all this stuff and understand all this stuff was that David Lipke had taught us the same lesson. Don't be afraid. So that's the first point I want to make. And what David told me over and over again was some of this stuff seems complicated and impenetrable and intimidating, and you might hesitate to even try to open the covers on that and learn it because you think you would fail and get confused. And he said, none of this stuff is that complicated. It kind of looks that way from the outside, but you're capable of understanding it. So don't be afraid. Open it up, look inside, figure out how it works on the inside. So at around the same time, while I was working at UT Dallas, I became one of the first people outside of Sun Microsystems to get his hands on a copy of Java. It was still called Oak at that time, and I learned it really early on, and compared to the other things I had available to me, it looked pretty cool, and I got into it a little bit, and as a result, I was signed on to write a book about it. And those of you who remember 1995 and Java at that time, remember that one of the things people were excited about was applets, and part of the supporting structure for that was this security model for untrusted code that was built into the Java virtual machine. So in the outline I proposed for this book, I was going to write a chapter on the security model, which was thoroughly undocumented. But no worries. One of the secret weapons of Java programmers back in those days was that almost alone among serious programming languages that people used in industry, Java came with a zip file then, of all the source code of its standard library. So no sweat that this is undocumented. I'm the kind of guy who was taught not to be afraid, and I can crack open this stuff and go in and read it and figure it out. So I'll write this chapter. And I got started on it, and then that was when I learned that really there was a small subset of Java library classes that we didn't have the source code for, and the security manager was one of them. Now, alert viewers will probably be saying, that's an elephant, not a turtle. Why is this picture here in a talk about turtles? Yeah, because the Rincewind and the elephant are standing on a giant turtle, okay? There you go. So I had committed to write this thing about the Java security model, and to my surprise, I found that I did not have the source code to the security manager. So I decided while I thought about that problem, I'd write the rest of the book and write the security chapter last. And what I eventually ended up doing, Java came with and still does come with a disassembler for class files. And so I spent the Super Bowl of 1996 sitting on the couch with a printout of the disassembled bytecodes of the Java Security Manager class and a printout of the Java virtual machine spec open beside me on the couch, reading and trying to interpret these bytecodes so I could understand how the Java security model worked. I'm telling you this as an example of, don't be afraid. It seems pretty intimidating. By about the beginning of the second quarter of that Super Bowl, I could mostly kind of read this as though it were source code. And I can still do that today. It turned out to be pretty easy to learn that skill. It hasn't been useful very often, but it's been useful more often than you might think. And 5 or 6 times in my career, the skill I learned watching the Super Bowl in 1996 has made me the hero of a project that was stuck because there was something we couldn't figure out about some proprietary bit of Java code. So point number 1, don't be afraid. Point 2, make it easy to explore. When I first started working with Rails, one of the things that struck me as difficult right off the bat was that Rails wasn't just one package. It was a bundle of different packages. And I understand why they did that. But nevertheless, at that time, I didn't know enough to even know necessarily if I'm trying to figure out what's happening in this part of the system or that part of the system, whether that's defined in Active Record or Action Pack or Active Support or any of those things. So like everybody else who was doing Rails at that time, I was using TextMate. And TextMate has this little known feature. How many people know about the projects feature in TextMate? Anyone? A few. In addition to just being able to open it up on a directory, you can kind of define projects and drag in code from all over the place. So I built this TextMate project that I always kept open in a separate workspace that had all of the Rails gems, not those versions, of course, back then, loaded into it as a project so that I could do full text searches across the entire Rails code base and find how things were implemented. No magic there, but I was just interested in lowering those barriers to being able to explore and crack open the source code and go in and figure out what goes on. A lot of people didn't and still don't like Rails because of all the magic. After about 2 months, it didn't seem like magic to me, because every time I would encounter something that seemed like magic and I wondered how that worked, I would go find out how it worked. And so a lot of the stuff that seems like magic to people pretty quickly seemed like perfectly ordinary, reasonable stuff to me that I understood how it was working inside. And once you have that level of understanding, you can much more reliably write correct code that uses those magical things because you know what's really happening. Still very useful, still saved me a lot of effort writing code here and there, but it was very useful that I knew what was going on under the covers. So make it easy to explore. Point 3 is to choose tools that make sense. We talked about abstractions leaking. Just before I encountered Rails, I worked a lot with an object relational mapping library that I won't name, but it tried to build a perfect, pure abstraction around the database that hid the database from you completely, to the point of having its own query language that was not SQL. And you would have to configure it to understand your schema, but then once you did that, everything looked like objects. And the person who wrote that framework was a friend of mine, and when I started veering off into Rails, he was really disgusted. And he particularly hated Active Record because the SQL leaked through everywhere. And but what I learned from this experience was, if you try to build a perfect abstraction that doesn't leak, Joel's law says that it will leak anyway, and it'll leak in subtle, insidious ways that bite you when you least expect it. And I learned to kind of like Active Record because Active Record leaks intentionally and in ways that are fairly easy to understand. I kind of like to refer to Active Record as an onion skin API. There are very low-level facilities, and then higher-level facilities are built on top of that, and on and on and on. But each of those layers is still documented and available to the end user. They're not hidden away deep somewhere. We're not allowed to use them. Can anybody think of another system kind of like that we use a lot? Unix. I really liked the talk yesterday, the systems programming talk yesterday. It was a talk about diving below some of those layers of abstraction that we've just kind of learned to live with and going to a much deeper layer. And it's, even if you never do that, it's great for you to kind of understand how Unicorn works and things like that. So, but can anybody think of any other system that a lot of us in this room use all the time that has this onion skin-like characteristic of Active Record? Ruby? The internet? The JVM? I know some people in this room work for a company that has banked on it a lot. Git, there you go. Git has that characteristic. In fact, parts of Git are known as the porcelain and the plumbing, right? But the plumbing's still all documented, and you can get into it and use it if you need to. But then the plumbing is what those higher level facilities, the porcelain, is built on. Tools like that leak in ways that make sense, and you can understand them. And I like to choose tools that have that transparent quality where you can, if you want to, without disassembling bytecodes and sitting on the couch with them, understand what goes on under the covers. There's a corollary to this point of also read documentation that makes things make sense. Raise your hand if you had trouble with Git when you first encountered it. Okay. Raise your hand if what eventually made it click was finding some documentation that explained some of the internals and conceptual foundations of Git. Okay, about half of those who raised their hand the first time. There are a lot of tutorials and documents that try to make Git make sense just by saying, here's how you use it to do the things you need to do every day. And that works fine until you need to do something a little different, and then you make a mistake, and you panic, and you don't know how to recover from it, right? For a lot of us, what finally made Git make sense and made us feel comfortable there was learning about a tool, learning about some documentation that explained the conceptual foundations of Git to us. And, you know, I'm not talking about, you know, once you understand that all of Git is mappings over Hilbert, endofunctors in Hilbert space, whatever that famous tweet was. There's a good example is a website that was written by a guy who works for me now, Sam Livingston Gray, called Think Like a Git. And he explains some of the graph theory principles that Git is based on and works through it at that level. And those kinds of things help a lot. Another good example, a blog post I came across a little while ago, and you know, I'm an Emacs guy, but this is a blog post about Vim, and I think the guy makes a really good point. For my first 15 years with Vim, I tried to learn it the same way you might learn a foreign language from a phrase book or Git from a typical tutorial, in a disconnected way. Use J to move down a line, CW to change a word, use YY to copy the current line into a buffer. You can get by this way, but it's a very simplistic approach. Advanced Vim users understand that Vim commands are a language unto themselves and that the key to being productive is understanding Vim's grammar consisting of the following parts of speech: verbs, nouns, and modifiers. How many of you have read this? It's awesome, isn't it? It really explains, the structure and the conceptual foundation of this vast Git command set, and gives you a framework to Git, Vim command set, and gives you a framework to hang all those little bits of knowledge on, and it makes a lot more sense that way. So, choose tools that make sense and documentation that reveals that underlying sense. Try building your own. This has always been a good strategy for someone who is seeking to become a master, right? Okay, no turtles here. Years ago at a conference, I saw Chad Fowler give a talk about Active Record it was a great talk called Active Record, Easy Living on the Golden Path. And basically he started with an empty TextMate window, and built a model class that would call out to the database to load instances of itself. And gradually, bit by bit, he built persistence operations directly into that class and then abstracted them away over the course of an hour, and ended up with a class that looked just like a typical Active Record model, and another class that contained some of the simplified, of course, internals of Active Record. Now, of course, there's a lot farther to go than that, and Chad's purpose in doing this was teaching it and then throwing it away. Not many of us will go build a new tool by ourselves as a way of learning about how our existing tools work, and then adopt our new tool as the thing we use. But even the act of building a simplified version can really teach us something about the tools we do use. Another good example of this is a screencast by Jim Weirich called Source Control Made Easy, where he sort of builds up Git from first principles, not at the code level, but explaining how you would design a revision control system to solve the first problem you encounter, and then the next problem, and so on and so forth, until he has built conceptually a command set that mimics Git's, and that's how he explained how Git worked to people. Another good example of that is, how many of you know the story of the creation of Rake? Jim will tell you that he accidentally wrote Rake in an afternoon. He never intended to write Rake. He's sorry for it. They had a conversation where they were frustrated with make, and he thought, oh, if only this were written in Ruby. But that would be crazy. And went back to his desk, and one of his coworkers said, well, what did you mean by that? What would it look like? And he said, well, let's try to build a little prototype. And about an hour later, he had version 1, essentially, of Rake. It was just that easy. So try building one yourself. The final point I want to make, when I talk to people about this, sometimes they will say, well, my employer is not paying me to do all of this stuff, to learn about what goes on under the hood of these technologies, to go read the source code of Rails, to go try building one myself so that I can understand it better. And I think that's just wrong. I think this is part of your job. I think a professional understands his or her tools. And this is part of what you're being paid for. Your employer might not understand all the reasons why this is part of your job, and a good thing, but nevertheless it is. I mentioned learning to read disassembled Java bytecodes as if they were Java source code, and I said, that hasn't been useful to me very much, or very often, but when it has been useful, it's been very useful. And you can all probably point to people in your organization, if it's not you, they're the ones you go to when you have the horrible, nasty stack trace from deep in the bowels of your framework or the framework that your framework uses or so on and so forth, and you can't figure out what to do, but I know so-and-so will be able to figure it out probably, right? And they're the ones who know this stuff, and they're valuable to your team because they know this stuff. And a company that thinks this is not part of your job is trading the future away for a small productivity advantage now. You do have to exercise some discipline. It's easy to waste a lot of time shaving yaks. But, it's your job to figure out how the things you use under the covers work. And you and your employer are just going to have to deal with that. You need to be prepared for some days that aren't fun. Sometimes when you crack open the tools you're using, you'll wish you hadn't. You'll find structures so rickety that it's amazing they even stand up at all. You'll find things that look like horrors from a different dimension. Unholy marriages. Sometimes you'll wonder if the author of this framework wasn't just playing a bad joke on everybody. But it's worth persisting because it's part of your job. Thank you.